Welcome back. So we're going to take a look at density of matter, particularly how to measure density. There are a couple different methods, and we're going to highlight both of those methods here in this video. And this is what you'll be doing in lab. You'll be taking measurements, and you're going to be using these two different methods, and you'll be working with multiple different types of matter. And we're going to find that there are, depending on the tool you use, it's going to have some sort of effect. And so we're going to want to take a look at what's happening here for that effect. So you're going to need to use sig figs, keep that in mind. Accuracy and precision, whenever you're taking measurements, all of those things are always a part of what we're doing. So keep those things in mind while you're doing this. Let's take a look at measuring different types of matter and finding out their densities. Welcome back, class. We're going to take a look at density today, particularly how to measure density. So you've seen things like this before. There's basic shape objects. So this is just a rectangular object, a spherical object, right? Here's a cylinder, right? Just something that's rod shaped, right? And then what I have here is, it's actually just modeling clay, all right? It's just modeling clay. And so, which it's going to serve our purpose. Notice I can bend it, and I can put it into this weird, very weird shape, right? I can break it off into little pieces and stuff like that, right? And so that's going to be important just because I'm going to be curious of something. So this extra bit, I'm just going to take it, put it off to the side. Don't need it right now. We'll just use this little bit here. And I've just sort of twisted it and turned it in some sort of weird little shape. Doesn't matter what the shape. I could have made it look like a balloon animal if I wanted to. Would have made a difference. Okay? So now, what we need to do is figure out how in the world do we get the density of these objects. Well, if you've looked at the notes, or if you remember even just your basic elementary level type stuff, and I say that because that topic is something that's brought up to us quite early in our lives, then we need some information. So density, we know, is mass divided by volume, right? That's how you actually calculate it. So this object here has mass, this spherical object has mass, this cylinder, all this stuff has mass. It's made up of matter, it's packed together. So density, about how much of that matter is packed together in a certain amount of space. And that space we measure as something we call volume, right? Okay, so a couple ways to do this. Early on, if you take something that's geometric, you're going to need some sort of tool that will help you get that geometric dimension. And this right here is a caliper, and it's easy to use. It basically is a ruler that has a little sliding mechanism on it. And so as you move this sliding mechanism, the caliper moves back and forth. And you can see that could be useful because you could use it to measure dimensions, right? You could use it to measure dimensions. So highly important tool. And of course, you'll be using these. That could definitely come in handy when you have to measure something about the sphere or this rod, right? But if you think about it, something like this, it's a little harder to be useful when you're talking about something that's so irregularly shaped like this piece of clay is, right? And the way that I just sort of twisted it and turned it. And so we have another way of approaching and figuring the volume of that. How much space is that object taking up by using a graduated cylinder. And so this one I already have some water filled up in it, and typically you use water for this. So you would fill the graduated cylinder up to some mark. It doesn't matter where you put it, you just need to make sure you have enough water. And then if you were to take this object and drop it into the graduated cylinder, well, what's going to happen? Well, we know the water level that's already there is going to rise up, and that rising water level has to be the amount of space that this object is taking up. And so without having to use calipers, because we really can't, right? We'd have to break this thing into pieces or try to reshape it. But imagine it wasn't modeling clay. Imagine it was like a piece of steel that was twisted like this, or whatever, or doesn't matter. It could be a rock, you know, a rock that you dig up somewhere. It would be really, really difficult to use this to measure it because it has all these little spaces and nooks and crannies and twists and turns and protrusions, right? So dropping it into a graduated cylinder, graduated meaning it has a scale right here on the side, and then knowing where the water level starts, you drop it in, the water level rises up. The difference between those two, that is going to be the amount of volume that's here. So now for density, we need two things, right? We need mass and volume. So to get mass, come with me, we need to go to the balances. So to measure mass, you're going to need something like a triple beam balance or something like a digital scale. So this digital scale, this is an air shield, and the air shield is exactly what you think it's for. It's so that whenever you put your object on the scale to measure, you close the air shield, and now the airflow that's going through the room, it doesn't push on the scale and the numbers will not go back and forth. So once you turn it on, you digitally will get some numbers back and forth. It'll give you your mass, and typically we're going to measure in grams. That's the typical measurement that we do use, okay? And then if you're using your triple beam balance, which is what we typically like for you to use in chemistry class, it just really is good at building up some good thinking skills, but good lab techniques. It gets you to really, it's a good manipulative. So you can see that there's a scale, and so there's the single scale right here. There's three different scales that are there, and what you typically do is the same thing though. This tray right here, you put your object on it, and you see right here, there's where the zero mark is right there. And you can see that there's that line that's balanced with it. And so what you need to make sure you do is put your mass, whatever it is you're measuring for mass, you put it on the scale and you see that that goes up. And now what you do is you just simply move these little dials back and forth. This one right here, you move a little bit to the right, and you keep moving all these. You keep making adjustments until this arm goes back down, and that point right there matches that point right there. They line back up. Then it'll be zeroed out. It will be balanced. Okay? Then you will have a good reading. And then you can see it's just basically a ruler. And you know how to read a ruler. We've practiced how to read a ruler, how to get your estimated digit, and then how to make sure that you're using the proper number of significant digits from that estimated value as well. We can figure out our uncertainty. We've talked about that, and you have lessons on that and notes on that as well. Okay, so now once we get the mass of all of our objects, we have everything we need to calculate density. One last thing I wanted to share with you about these triple beam balances. Let's just say, before you get started, that you see over there on the right where it's moving. Let's just say that the line on the left and the line on the right where the zero is are not lined up. That's what this dial right here is for. So if that part right there is low, so that line right there, if it's lower than the zero, you would take that right there and you would rotate and turn it up. You would rotate the dial forward away from you, which would raise that line up. If that is higher, if this bar right here is higher, then what you're going to do is the opposite. You're going to take this and you'll rotate it down towards you, which will bring that down and get it nice and zeroed out like you see here on the screen. Okay? All right, good luck. So we have the mass of all of our objects. All right? So now that we have the mass of our objects, we have the volume of our objects, and we get the volume by either taking the measurements of each object, right? And, you know, to do that, it's pretty simple, remember? You just open up the slide, right, on this, and you push it closed, and then you read the scale right there. So there's a 0 mark, and you just move from where the 0 was over to where you see that right now. Okay? And then so for something like this, of course, you would need length, width, and height, right? So you'd have to measure, what you would call length, what you would call width, what you would call height. You measure those 3 different dimensions, and you're good to go, right? So, and then for the spherical object, remember, there's a different equation for this, right? So for a spherical object, remember, it's like 4/3 pi r cubed, right? And so you have to, looking at that equation, you have to basically figure out this information here. And if you measure all of this, from side to side, you're getting the diameter. But you know that half of that is your radius, and that lowercase r in the equation, volume equals 4/3 pi r cubed. Well, you just take half of what that measurement is, correct? Right. And then, of course, when it comes to a cylinder, right, that again, you don't necessarily have length, width, and height, because there's only 2 ways you could measure this. You could measure it this way from one side to another, right? And that will give you the diameter of that spherical part. But then this thing also has what we call length or height. So if you typically when we talk about something horizontally left to right, you think length. But if you were to rotate it this way, you just think of it as height. So height and length typically are interchangeable. It's just a matter of perspective and where you're looking at it, right? And then, of course, this doesn't work for our modeling clay. So remember, what did we have to do? Drop it in the graduated cylinder and take a look at that. All right. So in lab, this is the type of stuff that you're going to be doing. What you have to make sure you do is that your significant digits, your accuracy, and your precision is spot on. You want to make really good measurements, really good, precise, accurate measurements every single time, because any measurement you take that you then put into your calculation introduces error that you want to avoid. All right? And so the stuff that you're going to be working with in lab, there are basic known values, and your job is to figure out those known values for what I give you for the different objects that are there. Okay, so finish watching the video and look at the calculations. Definitely take notes on that, and I will see you in class. Go ahead and get prepared for lab. It was good seeing you again. Bye. Measuring density. You have 2 methods, and which one you use really depends on the situation. So we had displacement method, where you basically take the object, you put it into a cylinder, a graduated cylinder that has a scale on it, where you know what the measurements are. You take those measurements. There's uncertainty within that measurement, like we've already talked about. And so depending on the type of graduated cylinder you use, you may or may not have more error in there, because the units may be more, as you saw. So for instance, you may have each of the lines on the graduated cylinder may measure 1 milliliter, or you might have a larger one where it measures 5 milliliters, each little line, each small scale value. And so the greater the number of the value for that can introduce greater error, because you can make more and more mistakes with the way that you actually take your measurement. So you saw that was the case, whether or not it was we use displacement method, where you put the object into water, and typically you use that one if you have the irregularly shaped object. That's a very difficult word. It's always been a difficult word for me to say anyway. So if it's not geometric in form, if you've got a chunky rock or something like that, something that has a bunch of protrusions or whatever, and it's not exactly a prism. It's not a cylinder. It's not spherical. It's not a cone. It's not a definite geometric form where you can use a geometric equation for volume to figure out the volume of the object. Then you use the displacement method to go ahead and figure out the volume of that. There's going to be some difference in, your measurements either through the displacement or taking the direct geometric measurements. And the two things, as we're saying, basically depends on you, depends on how consistent you are with your measurements. Always make sure that you're looking straight on to the measuring device. Don't be off to the side or up above it or down below it, because once you do, your view, your perspective of where that line is shifts. And you've seen this before. If you look at a ruler from the side, when you're looking this way, it looks like the edge of what you're measuring is shifting, and it's not. You're shifting. And so you just got to keep little things like that in mind. That's how you can introduce error. So depending on the tool, depending on how you use it, depends on the amount of error you have. And what you want to do is minimize as much error as possible in your measurements, which will minimize the error in your calculations. And you'll be correct more times than not. So everything we've been talking about here recently, all the stuff with sig figs, accuracy, precision, density, and measurement tools and things of that nature, that'll be in the lab. You'll be showing me that you know what you're doing with that. So you should be practicing that as much as possible. Come to class prepared. Shoot me any questions if you've got any. I'd be more than happy to answer those. As always, it's good to see you. I always got Bob here for support. And as always, it's good to see you. We'll see you in the next video. Take care.